So remember, when we are solving three variable systems, we have two things at our disposal: substitution and elimination. Those are the two things we have: substitution and elimination. So when we are solving the problem out, that's what we roll with. Again, reminder, there is no one-size-fits-all method that I can give you to solve the problem out. You have to look at the problem and figure out where you want to start first. So we're going to pick back up with that with example number 4. So with example number 4, we've got x plus 5y minus 2z equals negative 1. Negative x minus 2y plus z equals 6. And negative 2x plus 7y plus 3z equals 7. So that's our system. And our task is to find a solution for it. So first things first is we're going to look at the system and ask ourselves what we can do with it. Whether we can do substitution with it or elimination with it. So which way do you want to start? Which way do you think works for you? We got to get rid of one of these variables.
Elimination.
All right. Where do you want to start with elimination?
The first equation.
All right. So take the first two equations. X plus 5y minus 2z equals negative 1. Negative x minus 2y plus z equals 6. So our x's are already opposites of each other. So they drop out. Everything else gets added up. So 3y minus z equals 5. So we've eliminated the x. So now that means we've got to take two other equations and eliminate the x again. So we did the first and second equation. Now let's take the second and third equation. So since we already got rid of the x, we have to get rid of the x again. So the easiest way to do that for this problem, take the top equation, multiply it by negative 2. Now the reason why I chose negative and not positive is because I want to force the x's to be opposites of each other. I'm going to force them to be opposite so that they'll drop out. So if you multiply the top equation by negative 2, you get 2x plus 4y minus 2z equals negative 12. The other equation comes down. Now your x's are opposite. Drop. Negative 3y plus z equals negative 5. So we now have two new equations. 3y minus z equals 5. Negative 3y plus z negative 5. Let me pause for a second. Any questions before we continue? what I'm going to do is I'm going to piggyback on what Christian said. So he said start with elimination and start with the first two equations. So when you're pairing off equations, you've got three options. If you're going to pair off the equations, there's only three ways that you can pair them off. First and second, the first and second equation, the second and third equation, or the first and third equation. So if you're going to pair them off, there's only three ways you can pair them off. You can't pair an equation with itself. That's not going to get you anywhere. So, here's our system. What do you notice about both the Y's and the Z's?
They cancel each other out. 0.
They're all opposites. So, those are opposites, they drop out. Those are opposites, they drop out. That's 0 equals 5 plus negative 5, 0. Everything dropped out. And 0 is always equal to 0. So that means your answer is infinitely many solutions. The answer is infinitely many solutions. So if you thought that answer doesn't exist, well, you're wrong. It can't, it does exist, and it can happen. So that means if infinitely many solutions can exist, no solution can also exist. So if you find that happens, don't be scared of it. It just is what it is. Any questions with example 4?
Well, for an explanation, it has to be the same number on the left side and right side equal to each other.
That is correct.
Okay.
So 0 equals 0 is the most common way that it's going to show up. So that means if you have 0 equals 6, then that's no solution. So that would be an example of no solution. Everything dropping out, but both sides don't match. No problem. Any other questions? Example 4. So again, it's not necessarily that it's a hard problem. It's a problem that's going to take a little bit more time. Alright. So let's do one more basic example, then we'll take a break, and then we'll look at some word problems. So let me pause my recorder first. So our approach is we're going to, I'm assuming we're doing elimination. We're going to cancel out the y's. And we're going to pair off the first and second equation and the second and third equation. So let's take care of that. 2x plus 5y plus 3z equals 10. 3x minus y plus 4z is 8. So I'm assuming we're going to have to multiply the second equation by 5. So the first equation doesn't get touched. The other equation, 20z40, the y's drop. 23z. So there's the first equation we're going to work with. Put that off to the side, deal with it later. Bottom two equations. So again, we got to get rid of the y's now. We got rid of them from the first two. So the second two, multiply the top equation by -2. Remember, your goal is to force them to be something to be opposite of each other. So multiply the top equation, -6x plus 2y minus 8z equals -16. 5x minus 2y plus 7z equals 12. Y's drop. -1x minus 1z equals -4. So we've got our two new equations. You don't have to put the 1 in front of the variables. I just give it. Alright. Question before we continue. Like I said earlier, this is not the only way to solve the problem. This is just a way to solve the problem. One way. Alright, so looking at the problem now, this looks like a tailor-made elimination problem. I can get rid of whichever variable I want. So let's get rid of the x. Let's multiply the bottom equation by 17. Why 17? 1 times 17 is 17. That line there. 17x, 23z is 50. Negative 17x plus 17z minus 17z equals -68. X's drop out. 6z equals -18. Z equals -3. Now we're in business. So it takes a little work to get the first answer. Once you get the first answer, everything else takes care of itself. Take -3, put in whichever equation you want. So I'll go all the way back to the first one. 17x plus 23 times -3 equals 50. That's -69, 50. 17x equals 119, x equals 7. two answers. So to get y, you go back to where you started. Pick an equation and start working it out. So we'll use the first one because I feel like it. 2 times 7 plus 5y plus 3 times negative 3 is 10. 5y plus 5 is 10. 5y equals 5, so y equals 1. There's your 3 answers. So, from the time that we started this problem to now we're at its conclusion, that was 10 minutes. Some of you probably finished the problem well before we did. That's fine. Just know that when you do your quiz and when you do your test, the budget time so that you can solve them. Any questions on example 5? All right, here we go. You borrowed $200,000. Some of the money was borrowed at 8%, 9%, and some at 10% interest. How much was borrowed at each rate if the annual interest owed was $18,300, and the amount you borrowed at 10% was 4 times the amount you borrowed at 8%. So, here's example 6. So, if you know that you struggle setting up word problems, you should be actively paying attention and being prepared to ask questions. You know, chances are, you're going to get a word problem, you're going to have to set it up yourself and solve it yourself. Alright, so you've got $200,000. I wish I had some. Some was borrowed at 8%, 9%, and 10%. So you have $200K in 3 different accounts. So 8% is X, 9% is Y, 10% is Z. Make it very easy for yourself. So you borrowed $200,000 and you put it in those accounts. So one of your equations is pretty simple. X plus Y plus Z is equal to 200,000. One of them is very simple. Your interest owed is $18,300. So the interest from the first account, since it's 8%, is 0.08 cents. For the second account, 0.09Y. Third account, 0.10Z equals 15,300. So let's say I borrowed 200,000, some was borrowed at 8%, 9%, 10%, took care of that. Annual interest was 18,300, took care of that. The amount you borrowed at 10% was 4 times the amount you borrowed at 8%. So my 10% variable was Z. So Z has to equal 4 times the amount I borrowed at X. z is 4x. There's my three equations. Any questions on how any of them was set up? Again, don't wait until you see the 4 word problems on your homework to now panic about, oh, hold on, set them up. Or when you see the word problem that's on the quiz, or when you see the word problem that's on the test next week. Don't wait till then. But if we all good, then let's keep going. So here's our system. What should we do? Because now we're going to solve it. What's your plan of attack? I know what my plan is. What's your plan of attack? So take z equals 4x. So since z equals 4x, take 4x, plug it in the second equation. So that means 0.08x plus 0.09y plus 0.10 times 4x, 15,200. Clean this up. 4 times 0.10, 4. 4x, 2,300. This is 0.48x 0.09y equals 18,300. Alright, that'll work. So I've got one equation that I can work with. So what else? So I need another equation to pair off with it. You can put it in the first one too. Take 4x, put it in both of those equations. X plus y plus 4x equals 200,000. So that's 5x plus y equals 200,000. 5x plus y equals 200,000. All right, questions so far? Yeah, I'm not gonna lie, John, you don't have a calculator. These problems suck. But they can be solved. Alright, so I've got x and y. Now what? Say that again? I think two of y'all are trying to speak at once. Alright, so we're going to take the bottom equation and rewrite it. Rewrite as y equals 200,000 minus 5x. Or negative 5x plus 200,000. Either way works. So it looks like we're going to substitute. rewrite the second equation, and then plug it in. So again, you don't need permission to use substitution. If it's going to work, use it. You don't need permission to do elimination. If you feel that it's going to work, use it. $200,000 minus 5x equals 18,300. Time to do some work. 0.48x, 0.09 times 200,000 is 18,000 minus 0.09 times 5, 0.45x, 2,300. So all we got are x's now, so this works out. 0.03x plus 18,000 equals 18,300. 0.03x equals 300. So x equals $10,000. Good. Did I slip up anywhere? Sounds like I'm okay. So far, we now know that in 8% account, 8% account is $10,000 in there. So we still have to find the 9% and the 10%. Once you know one answer, now we can kick everything else off. So since that's 10,000, z is equal to 4x. That's 4 times 10,000. That's 40,000. Z represents 10%. So 40,000 went into the 10% account. $200,000 minus 5 times 10,000. So the last account has 150,000 in it. So there's your three answers. So now you know how much, what went into each account. No guesswork, just some solving equations. So if you were to try to guess and check that, number one, have fun with that. Number two, don't get used to doing it that way, because if any one of those would have been some oddball number, then you're screwed. You're guessing and checking and wasting your time. The algebra is not hard, it just takes a little work. Any questions on example 6? Not a hard problem. It's just one that you gotta follow where you're going. Anyone still copying example 6 before we go on to example 7? That'll definitely be the last one that we do today. Going once, going twice. So, let's move up. Alright, example 7. Example 7. Find the values of a, b, and c in the quadratic form of the equation y equals ax squared plus bx plus c. If it contains the points -2, 9, 1 comma -6, and 3 comma 4. So this is actually a crossover with something that you're going to be learning next unit, and that's how to write a quadratic function. So we need to find the values of a, b, and c. So you already know what your 3 variables are going to be. These 3 points are here to help you set up each of the equations. So we use those points to set up the equations. Let me show you how to do it. So -2 comma 9. -2 is an x value, y. 9 is a y value. We're going to put them in to the formula that they gave us. Y equals ax squared plus bx plus c. So that's 9 equals a times -2 squared plus b times -2 plus c. So of course we've got to clean that up a little bit. -2 squared is 4. So that's 4a minus 2b plus c equals 9. That's your first equation. Any questions on how we got there? Alright, let's do the next one then. 1 comma -6 works the same way. -6 equals a times 1 squared plus b times 1 plus c. Clean that one up. 1 squared is 1, so that just gives you a plus b plus c equals 6. That's a nice equation.
I thought it was -6.
Wasn't it? Yep, -6. Thank you. Three comma 4. So 4 equals a times 3 squared plus b times 3 plus c. 3 squared is 9, so 9a plus 3b plus c equals 4. So there's your system. There's your system. You just did some algebraic transformation. Any questions before we continue? Alright, so we got our system. Now we got to solve for A, B, and C. Now we got to do what they asked us to do. So, Where do you want to start? So, get rid of C in the first two equations. How are we going to do that? Elimination. So, both of those C's are positive. How are we going to get rid of that? There you go. Multiply one of the equations by -1. So I chose the second equation. No rhyme or reason. I just felt like choosing the second equation. 4a minus 2b plus c equals 9. -1a minus 1b minus 1c equals +6. C's drop out. So now we have to get rid of the C again. Let's use the bottom two equations. We can do the same thing. Multiply one of them by -1. So notice you're starting to get a lot going on in the problem, so you got to pay attention to what you're doing now. A plus B plus C equals -6. -9a minus 3b minus c equals -4. C drop out. So now we have two equations. 3a 3a minus 3b equals 15. -8a minus 2b equals -10. Computation is real. Any questions before we continue? Alright, so we still gotta solve for something. There's nothing times 3 that will give me 8. There's nothing times 2 that will give me 3. So I gotta force them to work. Someone just came off mute. So we have to force this problem to work. So we'll multiply the top by -2, bottom by 3. That's fine, that will work. You could have taken the top, multiplied it times 8, and the bottom multiplied it times 3. That will work too, in case you did it that way. 6b equals -30. -24a minus 6b equals -30. B's drop out. -30a equals -60. So a equals 2. Now we're in business. Then once we get 1, everything else takes care of itself. So we got a equals 2. So we're going to go back to one of the equations that we were previously working with. So since A is equal to 2, take 2, pick an equation, start working with it. 6 minus 3b equals 15. Negative 3b equals 9. So b equals negative 3. We got 2 parts. Now we just got to find the last one. Go back to our original equations and plug one of them in. So I'm going to use the middle equation. A was 2, B was negative 3, plus C equals negative 6. Negative 5 plus C equals negative 6. So C equals negative 1. So A equals 2, B equals negative 3, C equals negative 1. So your equation is y equals 2x squared minus 3x minus 1. Oops. That's definitely not negative 5. That's negative 1. Alright. Ignore all of that. See? Told you, mate, Mr. Lowe makes just as many mistakes as anybody else. Negative 5. Am I right now? Some of y'all are just going to let me go ahead with the wrong answer. Negative 5. So 2x squared minus 3x minus 5. And if that's wrong, we'll fix it again. You don't give up in these parts. Question on example 7. There's the full problem, so it all fits in the screen. So yes, there's a lot going on. So make sure that you write neat for my non-neat writing folks in the crowd, because I still have to figure it out.